5, part 5. Dear students, this part will be the continuation of the module 5. Non-preemptive scheduling. There are so many types in non-preemptive scheduling. First we will see first come first serve, okay, or first in first out scheduling. Okay. So how does it work? We have one example. Three processes with process IDs P1, P2, P3 with estimated completion time 10, 5, 7 milliseconds respectively enters the ready queue together in the order P1, P2, P3. Calculate the waiting time and turnaround time TAT for each process and the average waiting time and turnaround time assuming there is no IO waiting for the processes. Okay, the sequence of execution of the processes by the CPU is represented as P1, P2, P3. So these processes, there are three processes with the process IDs P1, P2, P3. They enter the ready queue in the order P1, P2, P3. Okay, so we have to calculate now the average waiting time and average turnaround time. Assuming the CPU is readily available at the time of arrival of P1, P1 starts executing without any waiting in the ready queue. Hence, the waiting time for P1 is 0. So, this is the assumption, assuming that when the P1 enters, okay, it doesn't have to wait for the CPU. It readily enters into the CPU with no waiting time. Waiting time for P1 is 0. Okay. So, then the waiting time for P2 will be 10 millisecond because it has to wait till the process P1 gets executed. Waiting time for process P3 will be 10 plus 5, 15 millisecond. That is the execution time of P1 as well as P2 together because the process P3 has to wait till both processes, that is P1 and P2, gets executed by the processor, and time taken by P1 is 10 millisecond, P2 is 5 millisecond to get executed. So that will be the total time of execution of P1 and P2 will be the waiting time for P3 process. Okay, the waiting time for P1 is 0 millisecond because P1 starts executing first without any delay or waiting time in the ready queue because it is made readily available to the processor. Waiting time for P2 is 10 millisecond because P2 starts executing after completing P1, and 10 millisecond is the time taken for the execution by the process P1. Waiting time for P3 is 15 millisecond. P3 starts executing after the completion of P1 and P2. So 15 millisecond is the time taken by P1 as well as P2, okay, together. So P3 starts executing after the completion of P1 and P2. So waiting time for P3 will be 15 milliseconds. So we have the same figure as it was shown in the previous figure, okay, for your reference. Now, average waiting time. Average waiting time is the sum of waiting time of all the processes divided by the number of processes. So, waiting time for P1, P2, P3 divided by total number of processes is 3. So, waiting time for P1 is 0. It need not wait for the CPU. Waiting time for the P2 is 10. Waiting time for the P3 is 15 millisecond divided by 3. That will be 25 by 3, 8.33 millisecond. Okay. So here these are the waiting times. Okay, 0 for first, 10 millisecond for the second process, 15 millisecond for the third process. Okay. So this is the execution time. 10 millisecond for P1, 5 millisecond for P2, 7 millisecond for P3. Okay. So the waiting time for P2 will be the execution time of P1. Waiting time of P3 will be execution time of P1 plus P2. Okay. Now turnaround time. for P1 is 10 milliseconds. Now what is turnaround time? The time spent in ready queue plus execution time. So for the process P1, the turnaround time is 10 milliseconds as it doesn't have the time spent in ready queue, that is 0 plus execution time 10 milliseconds. So 0 plus 10 milliseconds is 10 milliseconds. Turnaround time for process P2 is 15 milliseconds. That is, time spent in ready queue is 10 plus the execution time of P2 is 5. Turnaround time for process P3 is 22 milliseconds. That is, time spent in ready queue is 10 plus 15 plus the execution time of process P3 is 7. So it will be 22 milliseconds. So average turnaround time is the sum of turnaround time for all the processes divided by the number of processes. That will be 10 plus 15 plus 22 by 3. That will be 47 by 3, which is equal to 15.66 millisecond. Now turnaround time is the sum of average waiting time and average execution time. Okay, that we already know now. The average execution time. Okay, the average execution time is the execution time for all the processes divided by the number of processes. So the execution time for individual processes is 10, 5 and 7. So sum of these divided by 3. So 10 plus 5 plus 7 divided by 3, that will be 7.33 milliseconds. Average turnaround time. Okay, so average turnaround time is nothing but average waiting time plus average execution time. That is what is said in this particular line. What is average turnaround time? Sum of average waiting time plus average execution time. Average waiting time is 8.33. Average execution time is 7.33. So sum of those two will be 15.66 millisecond. That will be average turnaround time. Okay, so if we calculate in this way or directly we calculate, we'll get the same answer, 15.66 millisecond. Here also 15.66 millisecond. So the average turnaround time can be calculated by average of turnaround time for all the processes, okay, or as a sum of average waiting time and average execution time. Okay, so there are two methods to calculate average turnaround time. The next type of non-preemptive scheduling is last come first served or last in first out scheduling. Okay, it allocates CPU time to the processes based on the order in which they are entered in the ready queue. Okay, so CPU time allocation is done based on the order in which they are entered in the ready queue. The last entered process is serviced first. Last in first serve scheduling is also known as last in first out, where the process which is put last into the ready queue is served first. Drawbacks: favors monopoly of process. A process which does not contain any IO operation continues its execution until it finishes its task. Okay, that is called as monopoly. The process which does not contain any IO operation will continue its execution until it finishes its task. In general, last come first serve favors CPU bound processes, and IO bound processes may have to wait until the completion of CPU bound processes if the currently executing process is a CPU bound process. This leads to poor device utilization. The average waiting time is not minimal for last come first serve scheduling algorithm. The next type of non-preemptive scheduling is last come first served or last in first out scheduling. Okay, so here is an example. Three processes with process IDs P1, P2, P3 with estimated completion time 10, 5 and 7 milliseconds respectively enters the ready queue together in the order P1, P2, P3. Assume only P1 is present in the ready queue when the scheduler picks up it, okay, and P2, P3 entered ready queue after that. Now, a new process P4 with estimated completion time 6 millisecond enters the ready queue after 5 millisecond of scheduling P1. Calculate the waiting time and turnaround time for each process and the average waiting time and average turnaround time, assuming there is no IO waiting for the process. Assume all the processes contain only CPU operation and no IO operation are involved. Initially, there is only P1 available in the ready queue, and the scheduling sequence will be P1, P3, P2. Okay, because this is last in, first out. Initially, there was only P1, so P1 will be the first process, and then two more processes enters the ready queue, P2, P3. So P2, P3, the last entered will be the first one to go out, right? So in P2, P3, P3 comes first, and then uh, P2, P3, P3 comes first, and then P2. Then a new process P4 with completion time of 6 millisecond enters the ready queue after 5 millisecond of scheduling of P1. So between P1, P3, P2, now P4 also gets inserted, that is soon after P1. So the schedule will be, or the sequence will be P1, P4, P3, P2. Okay, so P4 enters the queue during the execution of P1 and becomes the last process entered the ready queue. Now the order of the execution changes to P1, P4, P3 and P2 as given below. Okay, so execution time of P1 is 10, P4 is 6, P3 is 7, P2 is 5, and then the waiting time of P1 is 0, waiting time for P4 will be uh, 10, and for P3 it is 16, P2 is 23. Okay, now let us calculate the average waiting time and average turnaround time for the same example. Okay, so we have the figure here which was shown in the previous slide, the sequence of the processes, okay, in which they are executed. The waiting time for all the processes are given as waiting time for P1 is 0 millisecond because P1 starts executing first. Waiting time for P4 is 5 millisecond. So waiting time for P4 is not 10, it is actually 5 millisecond. So why it is so? That is, P4 starts executing after completing P1. But P4 arrived after 5 millisecond of execution of P1. Hence, its waiting time will be execution start time of P1 minus arrival time of P4. That is 10 minus 5, that is equal to 5. 5 millisecond will be the waiting time for P4. Execution time of P1 will be 10, but the waiting time for P4 is not 10, it is 5 millisecond because it arrives after 5 millisecond of execution starting time of the P1 process. Waiting time for P3 is 16 milliseconds. P3 starts executing after completing P1 and P4. So sum of the execution time of P1 and P4 will be waiting time for P3. Waiting time for P2 is 23 milliseconds because P2 starts executing after completing P1, P4 and P3. So waiting time for P2 will be the sum of execution times of P1, P4, P3, that is 10 plus 6 plus 7, which is equal to 23. Okay, average waiting time will be the sum of waiting time of all the processes divided by the number of processes. So that will be 11 millisecond. The turnaround time for P1 is 10 millisecond. As you know, the turnaround time is time spent in ready queue plus the execution time, right? So time spent in ready queue for P1 is 0 plus the execution time is 10. So 0 plus 10 is 10 millisecond. Turnaround time for P4 is 11 millisecond. Okay, that is a time spent in the ready queue plus the execution time. So the time spent in the ready queue will be um, execution start time minus arrival time. That will be 10 minus 5 plus the execution time of P4. That will be 6. So it will be 5 plus 6 for P4. Okay, so be careful. Time spent in ready queue for P4 will not be uh, same as 10 millisecond. It will be execution start time minus the arrival time. Execution start time of the previous process is 10 minus the arrival time will be, arrival time of P4 will be 5 millisecond. So 10 minus 5 will be 5 millisecond plus estimated execution time of P4, that is 6 millisecond. 5 plus 6. Turnaround time for P3 is 23 millisecond. Time spent in ready queue will be 10 plus 6, 16, right? Plus the execution time of P3 will be 7. So 16 plus 7 will be 23. Turnaround time for P2 will be again time spent in ready queue is 10 plus 6 plus 7. This will be the time spent in the ready queue plus the execution time will be execution time of P2, that is 5 millisecond. So 5 plus 7 plus 6 plus 10, that is 28. So average turnaround time will be the sum of turnaround times of all the processes divided by the number of processes. That will be 18 millisecond.